Welcome to the WRAL Daily Download. I'm Amanda Lamb, and in today's deep dive conversation with WRAL meteorologist Elizabeth Gardner, we're going to talk about hurricane season and the challenge of bringing timely and accurate information to WRAL's audience. Elizabeth, welcome to the show. Thanks for being here. First of all, I know we are in the thick of things right now, but give us a little guideline here, a little tutorial on when does hurricane season begin, when does it end, that kind of thing.
So it begins on June 1st, but we typically see some storms developing in May. It seems like more years than not, we see that. So the National Hurricane Center is thinking about moving the start of the season up to May 15th because we tend to see some May storms. We saw 3 storms develop in June, and then everything was quiet after that. So it's interesting. We tend to see things crank up a little bit early in the season, then we tend to get a bit of a break. Now, it doesn't happen that way every year, but it seems more and more the storms are starting earlier and earlier. The season ends on November 30th, but there has been a tropical system somewhere in the Atlantic every month of the year. You hope that doesn't happen, but it has in the past.
Now, I know that every year you have predictions, right? And there are different organizations that make those predictions. I'm sure it's the National Weather Center. This year, NC State researchers predicted a very active season, right? With 17 to 21 named storms, 7 to 9 hurricanes. How do they do that? And how does this information help you guys with your forecasting?
So there are a lot of models that come into play with this. One of the circulations that they look at in particular is El Nino and La Nina. La Nina tends to bring us a more active hurricane season. The sea surface temperatures tend to be higher. We see less wind shear, and you may have heard that term before, but I don't know that everybody knows what that means. So if you think of a hurricane, it starts on the ocean surface and it towers, thousands of feet up into the air. Well, there's strong winds in the upper atmosphere, and when those winds are especially strong, they can tear the top of the storm off. That keeps it from developing and becoming stronger. So if there's a lot of wind shear, we don't see, storms, reaching their potential, if you will. So when we have a La Nina year, we tend to have very warm sea surface temperatures, and that's important because the ocean temperatures are the fuel for the storms. So, if we don't have ocean temperatures at 80 degrees or hotter, we tend to not have storms. Well, the sea surface temperatures in the tropics are almost always at 80. But when they climb into the mid to upper 80s, boy, there's a lot of fuel out there. So a La Nina pattern tends to bring us more storms than usual. Interestingly enough, when you look at consecutive La Nina seasons, if they're 3 in a row, the first 2 tend to be extremely active, like 2020, the most active on record. But we're, of course, now at 2022, which would be the 3rd La Nina in a row. Those years tend to be a little more quiet, and nobody knows exactly why. But these forecasts are just that. Even if we had a very active season, we could have no storms impacting the U.S. We could have a year that's inactive, like 1992 when Andrew plowed into Florida. There were no other storms that made landfall in the U.S., but it was a highly impact type of storm. So they're interesting, but they don't necessarily guide what we do. We take it storm by storm.
Gotcha. And another thing you just mentioned, Andrew, it's interesting how storms are named. I think a lot of people would love to know what that criteria is. Are names recycled? Are they retired? How does that work?
We do get that question fairly often. Who names those storms? There's a group called the World Meteorological Organization, and it's made up of meteorologists from all over the world because hurricanes and systems like this affect more than just the United States, the Caribbean, nations, South America, Central America. And so years ago, they tried to make it equitable. First of all, when they started naming storms in the 60s and 70s, it was all female names. Of course, they righted that wrong.
Of course, they should have, as well they should have.
And then they also made it multinational. So some of the names may sound unfamiliar to us because they're Spanish and they're French. And so they rotate all those through. But it's the World Meteorological Organization, that group of folks who picks the names. They do a list 6 years years out, and they do rotate the names. So Bonnie, for example, it's a B storm. And I think we've had a Hurricane Bonnie at least 3 or 4 times that I can remember, but none of them have done a lot of damage. So a storm like Floyd or Fran or those F storms for some reason tend to be just the right time of year to do a lot of damage. All those names get retired. And the criteria is purely that organization votes. They say this storm, did enough damage and killed enough people that we're going to retire that particular
because it brings bad memories to people.
Absolutely.
I gotcha. I don't know if it's my imagination or if we're just getting better at it, but we seem to be talking about storms more. So maybe we're forecasting them better than we were years ago. Is climate change playing a role in this?
Absolutely. Climate change, of course, means that we're warming the planet. The warmer the air is, the more moisture it can hold. So for tropical systems, that means the storm can get bigger, it can dump more rain, and sometimes there are more storms just because there's so much more heat that's heating the surface of the ocean, and that's really the key. So we have these waves, this time of year in particular, that come off the coast of Africa, and if the conditions are right, if there's no wind shear, and we have really warm sea surface temperatures, that storm's going to crank up. There are a lot of things that can come along to keep that from happening, but the warmer the planet gets, the more storms we're going to see.
Thank you so much. We're going to be back after the break with WRAL meteorologist Elizabeth Gardner to talk about what the hurricane season has been like so far and how it's stacked up against other seasons in the past. Welcome back to the WRAL Daily Download. I'm talking with Elizabeth Gardner about the 2022 hurricane season, how they predict, forecast, and cover storms from tropical depressions to hurricanes. So, Elizabeth, when you see a certain type of storm, is there one type of model or pattern that you see it, even when it's way out, and you go, oh my gosh, we really need to keep an eye on that? What is that pattern?
It's more of the time of year than anything. We tend to have, as we talked about earlier, some early systems that develop because the sea surface temperatures aren't as warm in May and June. We tend to not see those storms becoming monsters. They don't typically become category 3, 4, or 5. But once we get toward the end of the summer, we've seen all that heat build up. The sea surface temperatures are at their warmest. And so we start to watch the waves coming off the coast of Africa. We get into August, September, October, that's where most of the storms come from during that time of year. And anytime we see those start to develop, we really perk up and keep our eye on it. We also look at what the pattern is. Is it going to run into some wind shear? We talked about that, what that is. It'll tear the top of the storm apart. Or is it going to move into an area where the water temperatures are a little cooler? Or is there a plume of dust from the Sahara that's coming off the coast of Africa that dries everything out and keeps storms from forming? So we watch for patterns more than a storm itself. Once the storm forms, then we use the computer models to show us when that storm may strengthen. Again, we're going to be looking at the sea surface temperatures and where the wind shear is to be able to tell if this looks like something that it could, that could approach the United States. These storms are all steered by upper level winds or high and low pressure systems. So we'll also look at that pattern to say, oh, yep, it looks like we've got steering currents that could point this toward the U.S.
So far this year, we've had several storms. Hurricane Fiona had a big impact in the Caribbean, and now we're dealing with Ian. So how would you say this hurricane season, this storm season, stacks up against seasons in the past?
Well, we talked about the fact that this is another La Nina year, which tends to be fairly active. But this has not been nearly as active as 2020, of course, which was a record season, and 2021, which was right behind it. We ran out of hurricane names in 2020, had to go to the Greek alphabet. There were 31 named storms, which is incredible. So we're definitely slower than that. And we hope that it stays that way. The peak of the season happens late August through the middle of September. And so we're kind of coming out of the peak of the season, but it tends to stay pretty active into October. After that, the atmosphere tends to begin to cool enough that the storms aren't as frequent and aren't as strong.
So do you go back and kind of Monday morning quarterback after each season and say, well, we did this well, we could have done this a little bit better, wow, we were really on the mark with that one, and that one, we might have, missed the mark a little bit. I mean, how do you kind of look at that after the fact?
So they do that definitely, I'm sure, at the National Hurricane Center. We show their forecast path. We have a lot of models that we show. We do our own interpretation of that. We tend not to stray too much from what the National Hurricane Center is saying because, they've got 30 hurricane specialists putting this forecast together. We are the specialists for our local weather, 7-day forecast, what's going to happen right here. But we tend to, we look at what they say, and unless there's some, really big reason to disagree with it, they are the hurricane experts. What we would do is think about our coverage. How could we have covered this better? Maybe not how we would have forecast it better, but is there a way that we could cover this better so that people understand the risks and know what's happening?
Is it exciting covering a storm? I mean, obviously you don't want a negative impact, but it's also the aberration for what you do, day in, day out, 365 days a year. It's got to be interesting.
Well, you're exactly right. You never want a storm to make landfall and cause damage, but they are very interesting storms for sure. And the thing that I like about tracking hurricanes is they tend to last a long time. So you can watch them over time and see how they develop. You can see they move into different areas. And sometimes if they move over really warm ocean temperatures, they go through this rapid intensification, which is really fascinating. And then are they going to run into something that is then going to make them decrease in intensity? So they're fascinating to watch for sure.
Absolutely. Do you think your ability to forecast storms has become more and more accurate as the science and the technology has improved? I mean, it must have. I feel like now we can pinpoint things so closely, not just hurricanes, but tornadoes and many other things, snowstorms. How has that impacted what you guys do?
It gets better and better every year, and it's all about collecting data. So a computer model is just this. It's individual pieces of data that are collected, let's say for a hurricane. The hurricane hunters fly into the storm, and they'll drop instruments through it, and then they can track them. So we get that, pinpoint of time. But again, it's a pinpoint of time, and it's not time in immemorial. So we're not looking, we're not collecting data, once a minute on the storm. So the data that we have is great, and it gets better every year due to technology. We're able to sample storms more and more. The greater the sample is, the better the forecast is going to be, because all that gets fed into a supercomputer. It goes through a physics equation that describes the atmosphere, and then we can see what's going to happen down the road. But we're limited by our ability to collect enough data. For example, if we could sample every molecule in the atmosphere at a given second, we would have a perfect forecast. But it just doesn't work that way. We don't have a way to sample it. We're sampling things physically. And so, we're dropping instruments into a storm or, taking some readings from a satellite view, that sort of thing. And it's still not perfect.
I was going to say, it's not a perfect science, but it's pretty close. You get pretty close in terms of forecasting when and where something's going to happen.
Yeah. And the more data that we can put into those models, the better the forecast will be, and it gets better every year.
Well, thank you so much, Elizabeth, for
You're
your
welcome.
time. I know this
pleasure.
is a busy time of year. And this has been the WRAL Daily Download, a production of WRAL News. Check out my 2 true crime podcasts. What Remains focuses on solving cold cases with forensic science. Follow the Truth is about the murder of Michael Jordan's father in North Carolina in 1993. Find What Remains and Follow the Truth in your podcast app.